Daft is essentially a distributed query engine that's going to be replacing Spark, in a world after Spark. Essentially, we're a distributed query engine that's designed for multimodal data. So think images, videos, PDFs, tensors, etc. And we have a little pet name for the project. It's called Swordfish because swordfish is a fish that's fast. We didn't want like a land-based animal because that's like common. So we decided for some, seafood. Yeah, so we're transitioning from a pull-based partition-driven bulk synchronous model to a push-based morsel-driven streaming model. Why? We're optimizing for our most popular workloads, where memory efficiency and fast queries are the priority. Things like data loading into ML pipelines, ETL into cloud-based catalogs, and interactive data analytics. Here, in these type of queries, we never really need to materialize data in memory. It's always streaming from an input, streaming back to another output. And we really need fast queries. For interactive data analytics, you could be reading large amounts of data in S3, but only returning small amounts of data. And we need a streaming execution engine to support fast queries for that. Let's get into some implementation details. No, my slides didn't work. Okay, we'll go with this one. So each query is going to run on a single async runtime, single-threaded async runtime. If you're familiar with Rust, we use the Tokyo runtime for this. So each query is going to run on a single-threaded runtime, and each operator is going to be scheduled as a task. So if you're not familiar with async runtimes, you should think of it as an event loop, and each state of the event loop is like an operator that's going to compute at that time. And so data transfer between operators is via channels. We are a push-based system. Operators push their data into a channel for their parents to receive. In order to parallelize, operators are going to submit tasks to a separate async runtime. And this separate async runtime, or our compute and I/O runtimes, are multi-threaded. And they exist across the process, across queries. And these multi-threaded runtimes are going to be the runtimes that manage our compute resources, memory resources, and I/O resources. I like to think of this analogy as an analogy of a restaurant, right? You can think of the waiters as the query, and the waiters know the orders for each customer. They know what the customers want. And so they're going to submit the orders to the kitchen. And there's limited amount of cooks in the kitchen, similar to how we have limited amount of CPU resources. And so these are going to manage resources across the lifetime of the restaurant.